Hey learners, welcome to Connected. Today we are going to study about constructions and then learn the basics of it. So without wasting any more time, let's get started. The diagrams that were needed to prove a theorem or solve exercises in earlier chapters were not always precise. They were just drawn to give you a sense of the situation and to assist you in proper reasoning. However, there are occasions when an exact figure is needed, such as when drawing a map of a building to be built, designing equipments and different parts of a computer, or drawing road maps. Some simple geometrical instruments are needed to draw such figures. You must have a geometry box with the following items like number 1. A staggered scale of centimeters and millimeters marked off on one side and inches and their sections marked off on the other. Number 2. A pair of squares, one with 90-degree, 60-degree and 30-degree angles and the other with 90-degree, 45-degree and 45-degree angles. Number 3. A set of adjustable dividers or a divider. Number 4. A pair of compasses or a compass with a pencil holder on one end. Number 5. A protractor is a tool that is used to measure angles. All of these instruments are typically required when drawing a geometrical figure with specified dimensions, such as a triangle, a circle, a quadrilateral, or a polygon. A geometrical construction, on the other hand, is the method of drawing a geometrical figure using only two tools, an non-graduated ruler, also known as a straight edge, and a compass. You may also use a graduated scale and a protractor in construction where measurements are necessary. Some fundamental constructions will be discussed in this chapter. These will be used to create specific types of triangles. Now let's learn the basic constructions. Without providing any justification, you learned how to create a circle, the perpendicular bisector of a line section, angles of 30-degree, 45-degree, 60-degree, 90-degree and 120-degree, and the bisector of a defined angle in class 6. You will build some of these in this section, along with the reasons for why they are true. Let's start with the first construction of how to construct the bisector of a given angle. Given an angle ABC, we want to construct its bisector. Let's see the steps of construction. Number 1. We have to draw an arc to intersect the rays BA and BC, say at E and D, using B as the center and any radius. Number 2. Next, we have to draw arcs to intersect each other, say at F, using D and E as centers and a radius greater than half DE. Number 3. Then we have to draw the BF ray. This ray BF is the angle ABC's necessary bisector. Let's look at how this method produces the required angle bisector. Join DF and EF. In triangles BEF and BDF, BE is equal to BD, that is, radii of the same arc. EF is equal to DF, arcs of this equal radii. BF is equal to BF, that is common. Therefore, triangle BEF is congruent to triangle BDF by SSS rule. This gives angle EBF is equal to angle DBF by CPCT. Now let's learn to construct the perpendicular bisector of a given line segment. Given a line segment AB, we want to construct its perpendicular bisector. Now let's see the steps of construction. Number 1. First we have to draw arcs on both the sides of the line segment AB, using A and B as centers and a radii greater than half of AB to intersect each other. Number 2. Then we have to allow these arcs to intersect at P and Q. PQ is looking for new members. Number 3. Then we have to draw a line connecting PQ and AB at M. The requisite perpendicular bisector of AB is then line PMQ. Let's look at how this approach yields AB's perpendicular bisector. AP, AQ, BP and BQ are formed by joining A and B to both P and Q. In triangles PAQ and PBQ, AP is equal to BP, that is arcs of equal radii. AQ is equal to BQ, that is arcs of equal radii. PQ is equal to PQ common. Therefore, triangle PAQ is congruent to triangle PBQ by SSS rule. So, angle APM is equal to angle BPM by CPCT. Now in triangles PMA and PMB, AP is equal to BP. PM is equal to PM common. Angle APM is equal to angle BPM as proved above. Therefore, triangle PMA is congruent to triangle PMB by SAS rule. So, AM is equal to AM and angle PMA is equal to angle PMB by CPCT. As angle PMA plus PMB is equal to 180 degree linear pair axiom, we get angle PMA is equal to angle PMB, that is 90 degree. Therefore, PM, that is PMQ, is the perpendicular bisector of AB. Now let's learn how to construct an angle of 600 at the initial point of a given ray. We have taken a ray AB with the starting point of A. We want to construct a ray AC with CAB is equal to 60 degrees. We will discuss the following method of doing so. Number 1. We have to draw an arc of a circle that intersects AB, say at point D, using A as the center and some radius. Number 2. Then we have to draw an arc intersecting the previously drawn arc, say at point E, using D as the center and the same radius as before. Number 3. Then we have to sketch the ray AC as it passes through E. The needed angle of CAB is 60 degrees. Let's look at how this approach gives the necessary angle of 60 degree. Then we have to join DE. Then AE is equal to AD is equal to DE by construction. Therefore, triangle EAD is an equilateral triangle and the angle EAD, which is the same as angle CAB, which is equal to 60 degree. Now let's see some construction of triangles. So far, only the most fundamental structures have been considered. Following that, some triangle constructions will be performed using the constructions taught in previous classes and those mentioned above. Remember, from Chapter 7 that the SAS, SSS, ASA and RHS rules determine whether two triangles are congruent. As a result, a triangle is special if it has number 1, 2 sides and the included angle, number 2, 3 sides, number 3, 2 angles and the included side, and number 4, hypotenuse and one side in a right triangle. In class 7, you already learned how to make certain triangles. Let's look at some triangle constructions now. You may have noticed that in order to create a triangle, at least 3 parts must be provided. But not all combinations of 3 parts are appropriate. It is not always possible to create such a triangle uniquely if 2 sides and an angle are given. How to construct a triangle given its base, a base angle and sum of other 2 sides. With the given base, angle B and base BC, the sum of AB plus AC of the other 2 sides of triangle ABC. Then we have to construct it. Let's see its steps. Number 1. We have to draw the base BC at a point B. We have to make an angle XBC which is equal to the given angle. Number 2. Then we have to cut a line segment BD equal to AB plus AC from the ray BX. Number 3. Then we have to join DC and make an angle DCY equal to angle BDC. Number 4. We have to intersect CY with BX at A. Thus, ABC is the required angle. Let us see how you get the required triangle. Base BC and angle B are drawn as given. Next, in triangle ACD, angle ACD is equal to angle ADC by construction. Therefore, AC is equal to AD and then AB is equal to BD minus AD, which is equal to BD minus AC. AB plus AC is equal to BD. An alternative method can also be used. The first 2 steps will be the same. Then, a perpendicular bisector PQ of CD to intersect BD at a point A should be drawn. AC must be joined. Then ABC is the required triangle. Note that A lies on the perpendicular bisector of CD. Therefore, AD is equal to AC. The construction of the triangle is impossible if the sum AB plus AC is less than BC. Construction of a triangle with a given base, a base angle and the difference of the other 2 sides. You must create the triangle ABC using the base BC, a base angle, say angle B, and the difference of the other 2 sides, AB minus AC or AC minus AB. Clearly, there are 2 scenarios. Case 1. Let AB is greater than AC, that is, AB minus AC is given. Steps of construction. We have to draw the base BC and at a point B, we have to make an angle, say XBC, equal to the given angle. Number 2. Then we have to cut the line segment BD equal to AB minus AC from ray BX. Number 3. Then we have to join DC and draw the perpendicular bisector, say PQ of DC. Number 4. Then we have to intersect BX at a point A and then join AC. Thus, we get ABC, that is the required triangle. Let us now see how you have obtained the required triangle ABC. Base BC and angle B are drawn as given. The point A lies on the perpendicular bisector of DC. Therefore, AD is equal to AC. So, BD is equal to AB minus AD, which is equal to AB minus AC. Case number 2. Let AB is less than AC. That is, AC minus AB is given. Let's study the steps of construction for the case number 2. Number 1. First step will be the same as in case 1. Number 2. Then we have to cut line segment BD equal to AC minus AB from the line BX extended on the opposite side of the line segment BC. Number 3. Then we have to join DC and draw the perpendicular bisector, say PQ of DC. Number 4. At last, let PQ intersect BX at A and then join AC. Thus, ABC is the required triangle. You can justify the construction as in case 1. Construction of a triangle given its perimeter and its two base angles. Given the base angles, say angle B and angle C, and BC plus CA plus AB. You have to construct the triangles ABC. The steps of construction are: Number 1. We have to draw a line segment, say XY, equal to BC plus CA plus AB. Number 2. Then we have to make angles LXY equal to angle B and MYX equal to angle C. Number 3. Then bisect angle LXY and angle MYX. Let these bisectors intersect at a point A. Number 4. Then we have to draw perpendicular bisectors PQ of X and RS of AY. Number 5. Let PQ intersect XY at B and RS intersect XY at C. We have to join AB and AC. Thus, ABC is the required triangle for the justification of the construction. You may observe that B lies on the perpendicular bisector PQ of AX. Therefore, XB is equal to AB and similarly CY is equal to AC. This gives BC plus CA plus AB is equal to BC plus XB plus CY, which is equal to XY. Again, angle BAX is equal to angle AXB. As in triangle AXB, AB is equal to XB. And angle ABC is equal to angle BAX plus angle AXB is equal to 2 angle AXB is equal to angle LXY. Similarly, angle ACB is equal to angle MYX as required. Now let's study an example. Now let's do a fun exercise and revise some of the constructions. Now let us discuss the answers. With this, we have come to the end of today's class. I hope you enjoyed this chapter. See you all in the next class. Thank you.